Hello everyone. In this video we'll see another example on trigonometric Fourier series. So here again we have to find the trigonometric Fourier series representation for the given signal. Now whenever such kind of questions are asked, we first write the standard form of representing any periodic signal like shop t as a naught plus summation 1 to infinity. Now we have cos and sine terms, so it will be an cos n omega naught t plus bn into sine n omega naught t. This will be a standard representation. Now to represent this, we have to find the values of a naught, an coefficient, as well as bn, whose value can vary from 1 to infinity. At the same time, we have to find this term, omega naught. Now to find omega naught, we have a standard formula. Omega naught will be 2 pi by t, where t is nothing but the fundamental period, जिसको हम रिपीटिव पीरियड भी कह सकते हैं. तो इस वाले केस में अगर हम देखेंगे, इफ आई स्टार्ट फ्रॉम -1, so we'll be getting a shape like this and it terminates on this particular term. That means the signal repeat itself after every duration of this much time. Okay, even if I see for this one, it is starting from 1, then we have a slope, again it ends at 3. So the fundamental duration that we calculate t will be from -1 to 0, it will be 1 second, and from 0 to 1 it will be 1 second. So the total duration will be of 2 seconds. So based on that, we can write omega naught as 2 pi by 2, where this get cancelled, and omega naught will be pi. So first quantity omega naught we got as pi. Fine. At the same time, if I want to know the values of a naught, an, and bn, we have to start with the integrating formula. As first coefficient a naught will write, it will be 1 upon t integration from t naught to t naught plus t x of t into dt. This is the standard formula. Now to check what is t naught and what is t naught plus t, we'll start with the lower limit. So we have assumed the lower limit as -1, so we can write t naught as -1, and the upper limit t naught plus t, it will be +1. Sure it is. When I add equal amount of time here, it is 1 second. So we can write 1 by t is nothing but 2 integration from -1 to +1 x of t into dt. Now to integrate this term, we have to find what is x of t. Okay, so we have to check, go for this particular wave form, और जिसकी वजह से हम फाइंड आउट कर सकते हैं x of t क्या हो सकता है. Now to find x of t, we have two axes. One is x-axis and one is y-axis. On x-axis we have parameter t, and on y-axis we have amplitude, or we can simply say y. And this is given in the form of waveform. You can see ramp signal के form में दिया है. So based on that, we can go for formula of a straight line as slope y is equal to y2 minus y1 by x2 minus x1 into x. So at the vertical axis we have term as y, so we'll be write this as y is equal to, now we have to write the values of y2 and y1. As far as y2 and y1 is considered, so we can write y2 is nothing but the upper one, that is 1, minus lower value is -1, so this will be -1 divided by x2 minus x1. So x2 we are having 1 minus x1 we are having again -1 into x. How we are written this one? Y2 upper value corresponding to this x2 is 1, y1 is lower value corresponding to x2, which is again -1. So we'll be getting this as y is equal to 1 plus 1 divided by 1 plus 1 into x. अब अगर हम x की बात करेंगे तो at the RHS side, sorry, at the vertical horizontal axis we have x as t, so this will be t. So we'll be getting this as, this get cancelled, y is equal to t. That is nothing but our signal x of t. Y is nothing but होता है x of t. सो एक्स ऑफ टी इज इक्वल टू मिलेगा हमें टी. सो फाइनली आई एम राइटिंग इट हियर, एक्स ऑफ टी इज इक्वल टू टी. दिस इज मोस्ट इंपॉर्टेंट वेन एवर वी आर सॉल्विंग सच काइंड ऑफ क्वेश्चन, तो हमें सिग्नल जनरेट करना पड़ेगा. तो एक्स ऑफ टी जो है वो मिल गया टी. सो लेट्स राइट दिस 1/2 इंटीग्रेशन टी टी टी. अब टी का इंटीग्रेशन एज यू नो it will be t square by 2 with this limit. Now we'll put upper and lower limits. I will take 2 outside, so it will be 1/4 and this will be 1 square minus this term minus 1 square. So if you write it here, we'll be getting 1/4. 1 square is 1 minus 1 square is 1. So this will get cancelled and the first coefficient जिसको हम DC component भी कहते हैं, it will be 0. So the value of A naught will be 0. Now based on that, we have to go for valuing value of an and bn. So let's find an. So here we'll write an is equals to 2 by t, again integration from t naught to t naught plus t, x of t into cos n omega naught t dt. This is the standard formula. We'll put those values. 2 divided by time period is 2 with the limits -1 to +1. x of t is nothing but t multiplied by cos n into omega naught, जो हमें मिलेगा pi t into dt. We have find the values of omega naught already. Now we have to integrate this one. To integrate this, we will apply the formula as integration of u into v. It will be u into integration of v minus next term derivation of u, that is u dash into integration of v इंटू डी पी. कुछ इस तरह से फॉर्मूला होता है, डबल इंटीग्रेशन के फॉर्म में हम इसको लिख सकते हैं. विल राइट इट करेक्टली, यू इंटू इंटीग्रेशन ऑफ वी इंटीग्रेशन ऑफ यू डैश एंड डेरिवेटिव ऑफ यू इंटीग्रेशन ऑफ वी इंटू डी पी, इस फॉर्म में. सो दिस विल गेट कैंसल. विल इंटीग्रेट दिस टर्म टी इंटू कॉस का इंटीग्रेशन होता है साइन एन पाई टी divided by n pi over the limit -1 to +1 minus integration of now this one u dash यानी t का डेरिवेटिव. t का डेरिवेटिव जो है वो आ जाएगा 0 इंटू दिस एंटायर टर्म, सॉरी t का डेरिवेटिव हमें मिलेगा 1 इंटू इंटीग्रेशन ऑफ v जो कि ये टर्म है. सो विल राइट दिस एज साइन n pi t by n pi. Again we have to integrate one more time for this particular term. So we'll keep this as t into these terms sin n pi t by n pi with these terms. और इसका इंटीग्रेशन, अब साइन का इंटीग्रेशन होता है माइनस कॉस पाई. सो विल बी गेटिंग दिस टर्म एज माइनस कॉस n पाई t माइनस माइनस ये तो प्लस हो जाएगा n pi one more time n into pi with the limits -1 to +1. Clear? So we'll take this term t upon n pi into upper limit is 1. This term will be sin n pi minus lower limit is -1. So this will be sin n pi of -1 plus this term n pi into n pi nothing but 1 upon n square into pi square with these terms as cos n pi minus cos of n pi and this is -1. लेकिन cos of minus theta cos theta होता है. So this term will get cancelled. तो ये टर्म हमें मिलेगा as 0. एट द सेम टाइम यहाँ पर अगर हम देखेंगे तो साइन एन पाई है और ये भी प्लस हो जाएगा, लेकिन साइन ऑफ एन पाई, साइन का कोई भी एंगल पाई के अक्रॉस क्या होता है 0, तो ये भी टर्म हो जाएगा 0. सो बेस्ड ऑन दैट विल बी गेटिंग दिस कोएफिशिएंट a n as 0. सो द सेकंड कोएफिशिएंट ऑफ trigonometric Fourier series is again 0. This is most important term. Even if you add this one, we'll get 2 sin n pi. लेकिन sin का कोई भी एंगल पाई के मल्टीपल में 0 होता है. So this will be 0. Next we'll go for finding bn in the same manner. So we'll write for bn is 2 by t. Again integration from t naught to t naught plus t to sin n omega naught t dt. So this is 2 by 2 integration. X of t is nothing but t with sin of n. Omega naught is nothing but pi t with dt. This will get cancelled. Now if I integrate this one more time, we'll be getting this term as t into sin integration will be cos n pi t divided by n pi over the limit -1 to +1 minus integration of this term by u into v rule. We'll be getting इंटीग्रेशन t का डेरिवेटिव है 1, साइन का इंटीग्रेशन माइनस, जो कि हम यहाँ पर लिखेंगे प्लस cos n pi t by n pi into dt. I will be taking this minus sign outside, so we'll be getting t divided by n pi into cos n pi t with these limits. Now cos का इंटीग्रेशन it is nothing but sin pi, so हम डायरेक्टली लिखेंगे 1 upon n square pi square into sin of n pi t by n pi था तो इसका n square pi square आ गया with the limits -1 to +1. Now the same condition, this particular term का वैल्यू होता है 0, यानी कि sin n pi t का कोई भी एंगल अगर हम लेते तो ये आ जाएगा 0. Okay, now simply we have to put the upper limits 1 and lower limit -1 in this particular equation, so with that we can get the value of bn as, so upper limit 1 this will be -1 by n pi into cos n pi minus, we have to put -1 here, so this will be minus +1 by n pi into cos n pi, because cos of minus theta cos theta होता है, तो डायरेक्टली हम लिख सकते हैं cos n pi. This is as good as minus cos n pi upon n pi minus cos n pi divided by n pi. So addition of this will be getting -2 times cos n into pi. ओके, अब अगर हम बात करेंगे cos पाई की, तो cos पाई का वैल्यू -1 होता है एंड इट इज़ रिपीटेटिव. लाइक देखिए cos पाई इज इक्वल टू होता है -1 एंड cos 2 पाई इज इक्वल टू होता है +1. तो अगर इसके एंगल में मल्टीप्लिकेशन में इवन नंबर है तो प्लस आ जाएगा, और अगर ऑड है तो ये आ जाएगा माइनस. सो फॉर n इज इक्वल टू 1 3 5 7 सो ऑन, इसका वैल्यू -1 है, एंड फॉर 0 2 4 6 एंड सो ऑन इसका वैल्यू प्लस आता है. तो इसको हम लिख सकते हैं इन द फॉर्म ऑफ पावर एज bn इज इक्वल टू -2 बाई n पाई इंटू -1 रेस टू n. आप देख सकते हैं अगर हम n इज इक्वल टू 0 रखेंगे सो -1 0 विल बी +1, अगर हम 2 रखेंगे तो -1 स्क्वेयर विल बी +1. So this condition is satisfied. So finally we can write this as -2 by pi into -1 raised to n divided by n. Okay, so this will be our equation of coefficient p. Now we'll go for the last step, that is to fetch our equation. So we'll recall this concept. X of t is equal to दिया था a naught, a naught तो 0 है, प्लस समेशन n is to 1 to infinity an भी 0 मिल गया, so we're left with only this particular term. So we'll write for this as x of t is equal to summation n is equal to 1 to infinity into bn as -2 by pi into minus 1 raised to n divided by n multiplied with sin of n pi into t. अब अगर हम इसको एक्सपांड करेंगे, स्टार्टिंग पुटिंग विद द वैल्यूज 1 up to infinity, so this equation hold. If I put 1 here, we'll be getting minus 2 by pi into minus 1 raised to 1, it will be minus, तो ये प्लस हो जाएगा और ये भी 1 है, तो we'll be getting this as sin pi t. If you put 2 here, तो माइनस 1 का स्क्वायर तो प्लस 1 होता है, सो दिस इज माइनस, तो ये हमें मिलेगा माइनस 2 बाई पाई, ये भी 2 है, तो ये दिस विल गेट कैंसल एंड विल बी गेटिंग दिस एज साइन, एन की जगह पे 2 है तो ये आ जाएगा 2 पाई टी, यहाँ पर तो पाई टी था, प्लस इफ आई पुट 3 इन दिस इक्वेशन, तो माइनस 1 का क्यूब माइनस होता है, माइनस माइनस प्लस, तो ये मिलेगा 2 डिवाइडेड बाई एन 3 है, तो ये आ जाएगा 3 पाई इंटू साइन ऑफ 3 पाई टी प्लस so on up to infinity. So this will be our Fourier series representation, that is x of t. So I hope you understood this question also. Thank you.